Alright, so we're going to start out with our second method of solving quadratic equations by use of the quadratic formula. So the quadratic formula is derived by completing the square on the general quadratic equation. So we have ax squared plus bx plus c equals 0. Okay, so with this one, we're going to solve by completing the square. As you can see, we have set up here, just like in our formula I just read off, ax squared plus bx plus c equals 0. So now we need the coefficient of the squared term must be 1. So to do that, we need to get rid of that 2. Okay, so in other words, our a value must be 1. So we need to get rid of that 2, in which case you divide everything by 2. And it left us with x squared plus 3 halves x minus 1 half equals 0. So that's our first step, is going ahead and getting the coefficient of the squared term to equal 1. So in other words, our a value right here needs to be 1. Well, we have a 2 here, so we had to get rid of. Okay, so we got rid of that, and we're left with 1 there, and then 3 half x minus 1 half equals 0. So now let's get the constant on the other side of the equal sign. All right, so we subtracted, well, I should say we added 1 half to both sides, in which case I got 1 half on the right here, and 3 halves x over there. So let's go to our third step. Let's complete the square. So to do that, so our b over a value was 3 over 2 that we had. Okay, from the equation, we have 3 over 2x. So we're always going to multiply that by 1 half, which gave us 3/4 in this case. 1 half times 3 halves is 3/4. And then we're always going to square the result. So we're going to square the 3/4 to give us 9 over 16. Then we're going to add 9/16 to both sides of the equal sign. So we added it over here to our x squared plus 3 halves x plus 9/16 equals 1 half plus 9/16. So then we need to get a common denominator so we can add these, in which case 8 over 16 is 1 half. So then we can add those two fractions, and that came up to give us 17 over 16. Now we can factor things out a little bit. So in which case, you should see 3/4 like we got right here before we squared it is what factors out of this equation up here. Okay, that's how it's always going to play out. So 3/4 is the coefficient of x, so we have x plus 3/4 squared. In other words, when we factor this equation out right there, it's the same thing as saying you have x plus 3 over 4 times x plus 3 over 4. That's where they got the x plus 3 over squared, and that equals your 17 over 16. Okay. Now that we've got that factored out, now we can get rid of this squared, and we can go ahead and square both sides, or take the square root, square root of both sides, so get rid of that squared. In which case, when we did that, so we took the square root of both sides, and that takes away the squared on the left-hand side, so that's x plus 3/4, and that equals plus or minus the square root of 17 over 16. And therefore, that can be simplified down to taking the square root of 17 over the square root of 16, and that's how they got the 4 on the denominator. So we still got plus or minus square root of 17 over 4. Then we're going to need to subtract 3/4 from both sides. So we subtracted 3/4 to get rid of that over here, and that left negative 3/4 on the right-hand side. So negative 3/4 plus or minus square root of 17 over 4. And that can be simply be rewritten since they both have the same denominator of a 4. We can simply write that all over 4. We can say negative 3 plus or minus square root of 17 over 4, which is very similar to the setup here of our quadratic formula. So the quadratic formula Solutions of any quadratic formula of the form ax squared plus bx plus c equals 0, where a does not equal 0, are this formula set up right here. Negative b plus or minus square root of b squared minus 4ac divided by 2a. All right, so some things to take away from here. So write the equation we solved in that form so that a, b, and c can be identified correctly. When you have the equation there, represents the two solutions of x, right? You have a plus and minus. So you take the plus on one time, and then you take the minus on the other, because this means there are two solutions. All right, so then also notice the fraction bar runs under negative b and under the radical. It's not just, as I said up here, this is wrong, and this is on the right. And the fraction bar goes all the way across, okay? Everything is above 2a. When deriving the quadratic formula, using the plus or minus allows us to say that square root of 4a squared equals 2a. Okay? And the quadratic formula is a very important result, and one that we will use often. It should be memorized. So that is something definitely to make note of and get this memorized in your head. It's something you will definitely use moving forward. So solve using quadratic formula. Well, looks like we've already kind of got it in our ax squared plus bx plus c equals 0 format. And we need to identify the values of a, b, and c. Well, we see a equals 4, b is a negative 2, and c is a negative 7. Okay, so now we can say, instead of putting an x out there, since we're dealing with g's in this formula, we can say g equals our formula for the quadratic, or our setup for the quadratic formula. Okay. So now we can substitute in our values of 4, negative 2, and negative 7. And therefore, that's what we got written out there. Then we perform the operations to simplify. So negative times negative 2, positive 2, plus or minus the square root of negative 2 squared is a positive 4. And then we have minus a 4 times 4, which is 16, times negative 7, which gives us negative 112. So we have 4 minus a negative 112 all over 2 times 4, which is 8. Okay. So now we just simplified this by understanding that when we have a negative, we're subtracting by a negative number that turns that into a plus. So that turns it into a plus sign. All right. And now we can add 4 plus 112. That gives us 2 plus or minus square root of 116 over 8. And then let's go ahead and break up this 116 and the two numbers, work this out. Let's look at, we can say maybe 4 times 29. Okay, so we can say 2 plus or minus square root of 4 times 29 all over 8. When we do that, square root of 4, take the square root of 4 times the square root of 29. Well, square root of 4 is 2. That's where we got this 2 right here. And we still have square root of 29. So now we could possibly do this a little bit easier, right? We can break this up into saying 2 over 8 plus or minus 2 over 8. Let me go make that whole fraction there. 2 times square root of 29 all over 8. So we can simplify these fractions here. So this could go down to 1/4, and this can go down to 1/4 as well. And when we do that, we're simply left with saying that we have 1 plus or minus square root of 29 all over the value of 4. And with that, the answer we should get is 1 plus square root of 29 over 4 and 1 minus square root of 29 over 4. All we did there was write out both solution sets because we have this plus and minus right there. All right, so let's solve this one using the quadratic formula. Y squared equals 6y minus 25. So is it in the form? No, so let's get that form, let's get that equation in that form. So to do this, let's go ahead and subtract 6y and add 25 to both sides. So when we do that, we subtract 6y from both sides and we added 25. So y squared minus 6y plus 25 equals 0. So now we can pick out what our a, b, and c values are, which 1 and -6 for our b and c for 25. So a is 1, which is good. We're looking good so far. And now we just need to use the quadratic formula. And we need to substitute in our values of a, b, and c. When we do that, get this set up here. So now we should be able to perform the operations. And therefore we should get positive 6 plus or minus square root of 36 minus 100, all divided by 2. And then we can just simplify what's inside here, it looks like. Saying 36 minus 100 gives us negative 64. Now if we have a negative 64, square root of negative 64 I should say, you should say, well, you can't really do that, right? Unless you do an imaginary number. So that's where what we've done previously comes into play here with complex numbers. So therefore, when we take the square root of negative 64, that is square root of 8i. Square root of negative 64 equals 8i. Because if you do this, that's like saying you take square root of negative 1 times the square root of 64. Well, 8 times 8 is 64. And the square root of negative 1 is simply an I. So therefore, we can take an 8 out and an I. So we got 8i right there. So we should get 6 plus or minus 8i divided by 2. And then we just need to work those out as far as how it's set up right there. We have 3 plus 8i divided by 2 and 3 minus 8i divided by 2. On the top one there for the plus, we can simply say we've got, because we can simplify this because 8 over 2 is simply 4. So we can say y equals 3 plus 4i. Now at the bottom we can say y equals 3 minus 4i. So the overall solution of this set is 3 minus 4i and 3 plus 4i. So again, don't forget about your imaginary numbers and complex numbers altogether, because they will come into play. All right, so let's use this in solving the quadratic using the quadratic formula. So is this one set up in that form? No, so we got to write it in the correct form. So we take the equation and multiply using FOIL. So if we do that, we take our 3p times 3p, 3p times 4, negative 1 times 3p, and then negative 1 times 4. So we should get 9p squared, and then 12p minus 3p, which is 9p, and then negative 1 times positive 4 is negative 4, equals 3p minus 5. So now we can subtract 3p and add 5 to both sides to get rid of it over here. So we can simply subtract 3p, add 5 to both sides, subtract 3p, add 5. Okay. And we're left with, again, when we do that, we get 9p squared plus 6p plus 1 equals 0. So now we can identify our a, b, and c, since we got it down to equal 0, and then we use the quadratic formula and plug in our values. So we got our a is 9, b is 6, and c is 1. And we plug those in. Then we perform the operations to do so. And you get negative 6 plus or minus square root of 36 minus 36 divided by 18. Well, what's 36 minus 36? 0. So square root of 0 is 0. So you should get 6 plus or minus 0 divided by 18, which is negative 6 divided by 18, which can be simplified down to negative 1/3. So the only solution to this equation is simply negative 1/3. Okay, so solve using the quadratic formula on this one. So now we've got one set up here with fractions. Don't let that scare you because we still got things set up as we need to quadratic formula wise. So notice the equation is already in the right form. However, working with fractions in the quadratic formula would be difficult. Eliminate the fractions by multiplying the equation by 12, the least common denominator of the fractions. So they got that by saying, well, least common multiple is simply by saying we had a 3 and a 4. Well, if you multiply those together, 3 times 4 is equal to 12. So therefore, 12 would take away those fractions from all of those. So if we do what they said and multiply both sides by 12, we'll get the 4 will go away here and give us a 3 on top because 12 divided by 4 is 3. 12 divided by 3 is 4. And then we simply have 12 divided by 4 is 3, and 3 times 3 is 9. And 12 times 0, of course, is still 0. So now we can identify our A, B, and C values. And let's use the quadratic formula. We've got A is 3, B is negative 4, and C is 9. So we can substitute those values in. And then we can simply just perform the operations. Okay. So inside there, they're saying that 16, because you got negative 4 squared is 16, minus 4 times 3 times 9, which is 108. So we should get a negative 92. And that's the numbers they got right there underneath the square root. And negative 92. So negative 92 can become 2i square root of 23. And to do that, just got to play around with the numbers here. Again, you take square root of negative 1 to get that I times the square root of 92. In which case they went in here by going in by 2's and doing a factor tree. And when they came up with, they should have got 4 times, looks like 23. A simple way that they looked at it by saying that, because 4 times 3 is 12. And then the carrier 1, and then 4 times 2 is 8, and 1 is 92. All right, so then you can simply say this is 2 times 2. So 2 will come out, and you're left with square root of 23 is left under there. That is how they got this guy right there. Okay. So now, with that, as far as how they did that, they set that up into negative 4 times 23. I wrote a little bit different how I played out with it. But they got the same answer, right? Because you still had to take the negative 1, there's a negative 1 there, so square root of negative 1 times square root of 4 times square root of 23. Okay, so we got 4 plus minus 2i square root of 23 divided by 6. So let's factor out 2 in the numerator. So we can take a 2 out of the top, right? And if we do that, then we should be able to simplify this. In which case reduce the fractions. So we should get this 2 goes in here 3 times. So we have 2 plus minus I square root of 23 divided by 3. And so then we should have our overall solution for this set, because we have plus and minus. We have 2/3 minus square root of 23 over 3i, and 2/3 plus square root of 23 over 3i. Now I don't like how they've written these solutions out. You can simply leave it how you have it written right here and simply say you have your solution set. I'm going to change this up, equal sign. Your solution set could simply be 2 minus, I'll leave the I in front, so therefore you don't get confused that it's behind, all divided by 3, and 2 plus I square root of 23 all divided by 3. Those are the proper way to notate the solution. Do not use those solution sets. Those are no good. I don't like how they put the I right there. They talk about, and we're dealing with complex numbers, when we're learning those, we simply made a statement, don't put it behind the square root because it can get confusing, even in front of it, okay? All right, so that takes care of solving quadratic equations by use of the quadratic formula. So now we're gonna do our check understanding. Got a couple problems to work at in Canvas over those. I'll see you next time.